Alright everyone, welcome back to Cody's Lab. So I got my friend Arthur here, and we're standing on the side of I-80 at 3 o'clock in the morning, and we're going to be mining some platinum from the side of the road. We got our brooms, we're going to scoop up some dust. The idea is that platinum is lost to your catalytic converter, and we can recover that platinum because it's going to be on the side of the road here. So we're going to get us a sample, and I'm going to process it and see if we can actually do it. Ready for this?
Let's get going.
All right. Looks like it's mostly gravel and stuff, but I'm sure there's definitely some platinum there. Hopefully I'll be able to recover it. Okay, so I've made it home with the bags of dirt. Now, all I've got to do is process this to remove the pieces of gravel, the cigarette butts, and the tire pieces. So the first thing I'm going to do is remove all of the large pieces by sifting it down. I don't think I'll lose very much platinum by taking these large chunks out of there, because ultimately the platinum particles are going to be incredibly small, possibly even just a few atoms in size. That also means I really can't use gravity methods to separate them because they're going to flow basically just the same as any mud particle would. This material here appears to be primarily ground up concrete from the freeway, and there's a lot of little bits of rubber strewn throughout it, probably coming from tires. So I've been screening this material down even farther using this coffee filter thing that I found, and it works to get this incredibly fine. It's basically dust by the time it's done with it. And I think what I'm going to do is I'm going to take a sample and just do a fire assay on it. 146 grams. You know what? That's about right. I think these can do up to 150 grams a sample. In this video, I'm not going to be processing massive amounts of platinum. I'm just going to be taking a sample and seeing if there's platinum there or not. Perhaps I'll do another video sometime where I process much more material and see if I can actually get a valuable bead going. Anyway, let's mix up the flux. This is primarily sodium carbonate, and that will act as a solvent which will actually dissolve the rock dust. There's also some borax to help thin out the liquid, and the orange that you can see is actually some lead oxide. The lead oxide will react with a little bit of flour that I've got in there, which is actually those little lumps you see there, and the flour will take the oxygen from the lead oxide, forming lead metal, which will then dissolve the platinum and then bring the platinum down to the bottom. Let's add this flux. Looks like I'm going to need a little bit more. This is a fresh, clean crucible, by the way, so there's no contaminants of any foreign metals other than what was actually in our sample. Time to load the sample into the furnace. So while that's cooking, I thought I'd talk to you guys about why I think that there'd be platinum on the side of the road. You see, I've done some work on catalytic converters, and I noticed that new ones have way more platinum than old ones. In fact, I figure that after about 100,000 miles, the catalytic converter loses about half of its platinum. Along this particular section of road, there's roughly 10,000 cars that go by per day. That means that over a 1 mile stretch of road, in 10 days, there's been 100,000 miles driven, which means there'd be half the amount of platinum in a catalytic converter dumped onto the side of the road. Since catalytic converters contain 2 to 3 grams of platinum, it seems reasonable that after about a year, there could be up to an ounce of platinum per mile of road. Now, of course, most of that platinum probably doesn't actually stay on the road, but I'm certain that I'm able to accumulate some of it. All right, let's see if it's ready. It looks hot enough. Seems to be fluid. Let's dump this out. Okay. There we go. There's the lead. The slag was rather pretty, but it's the lead that's going to contain the platinum now. So let's break this out of there and then put this into a cupel and burn away the lead. Now that the flux is no longer coating it, the lead will now oxidize in the furnace. And this bone ash pot here will absorb the lead oxide. The precious metals, however, will not oxidize, and so they will remain as a metallic bead sitting right in the middle of this. At least, that's the idea. It's now the moment of truth. Let's see if we've got anything here. Alright, it's very hot. I see a bead. Yeah, there we go. Just flashed over. Now just looking at this, I can tell you right now that that is a bead of a very high melting point metal that obviously does not oxidize. Which means we've actually got some platinum group metals here. It's not a very big bead though. I know that the bead is a platinum group metal because silver or gold would have formed a very shiny bead, whereas this one is a dull gray color. This tells me that the bead of metal didn't actually melt in the 2000 degree Fahrenheit furnace, and so it's still an alloy of lead and platinum. So I need to heat it up a little bit hotter. I'm going to use this oxy map gas torch here to do it, and hopefully if I'm able to reach the temperature that platinum melts at, I'll be able to expel the last of the lead and I'll be left with a pure shiny bead of metal. There we go. Now this flame will be able to get much hotter than the furnace got. Now that we've gotten rid of the last of the lead, the bead is now shiny. Okay, so I've got the bead in the calipers. You can see the size there on its largest axis. Because the bead is kind of pancake shaped. So let's see if I can measure the other dimension now. There's its smallest dimension there. Let's see if this scale is accurate enough to weigh this little bead. Okay, it's on there. Yeah, you know what? As accurate as the scale is, it's not measuring anything. So I now have the bead inside of a test tube sitting in a beaker full of warm water. To make it so we can see it better, I have a magnifying lens here. Should be able to see a slightly zoomed in version of this, so you can see it a little bit better. Now I'm going to put in a couple drops of aqua regia. Just a couple of drops of this. See if it starts reacting with it. Yep, it's dissolving it. See it turning red? I think it's working. There's not very much metal in there to dissolve though. This right here proves that it's not silver because silver does not react like this in aqua regia. Silver would just turn white and not dissolve. So now that it's done reacting, I've pulled the solution up into this pipette so that I can remove it. But there's a little bit of residue right here. I think that's actually my silver there. I'm going to take this solution out of there. I'm going to evaporate it down to remove the nitric, and then I'm going to see if I can precipitate the platinum out of it. Now that I've removed the nitric acid, I've reconstituted the solution and put it back in a vial. And now I'm going to drop in a few grains of ammonium chloride. There they are. Now this should precipitate out the platinum. So after sitting for a while, the solution has turned a more yellow color, and as you can see, there's a little bit of a yellowish precipitant on the bottom of the jar, and also floating on the top of the liquid. So I've confirmed the presence of platinum. Excellent. After letting it settle for a little while, I siphoned off the fluid, and I've separated the yellow precipitant, which you can see in this vial, from the liquid, which I've placed in another vial here. Now I'm going to add a crystal of sodium chlorate to this. The sodium chlorate should react with any palladium present and drop the palladium out of solution. You can see that it's gained a little bit of a red color. If you look carefully, you can see some little red specks. I think that's my palladium there. Here's the two side by side. You can see over there on the right is the platinum precipitate, and over here on the left is the palladium. Over here is the speck of material that wouldn't dissolve in the aqua regia. My guess is it's primarily silver, but it could also contain iridium and ruthenium as well. Now it wasn't pure platinum, but I think that bead was probably roughly half platinum. But I went through the calculations assuming that it was pure platinum. You guys can check my work, but I came up with a value for 6.7 grams per ton of the fine sifted stuff. The bulk material might be significantly less. But that's pretty impressive considering that that's just laying on the side of the road. That would be considered a valuable ore, actually. Anyway, hope you guys enjoyed. I'll see you next time. Arthur made a quick video about the chemistry of catalytic converters. I'll post a link here and in the description so you guys can go check it out.